Hi, welcome to video 4.2, 4.3e. This is the last in the series for 4.2, 4.3. So again, just more areas and properties of definite integrals. So here's number 30, same idea. They want you to use a geometric formula to find the answer. So again, you can tell it's x-axis. So bottom is x-axis, top is y equals a, unknown a, minus the absolute value of x. Left border x equals negative unknown a. Right border x equals a. Okay, so we're going to have to draw this function f of x equals a minus the absolute value of x. So over on the side here, you know y equals the absolute value of x is that v shape turning up. I know I can do this. There we go. So if I put a minus in front of it, flips it over the x-axis. If I add a positive a to it, and they do say a is positive, it's going to move it up a, okay? The x-intercepts, you'll need to know where those are because you're going to need to know where they are with respect to the left and right borders. If I replace y by 0 in this equation, I end up with x equals plus or minus a. So it does turn out that the graph actually does intersect the x-axis at the left border and the right border that they're giving you at x equals negative a and x equals a. Okay, so we end up with a triangle, this time not a right triangle. Of course, the area of that triangle, they want you to use a geometric formula, which is nice because this would not be fun to do by hand. You don't know what a is. And remember, we did the absolute integrals of absolute value. This is actually a lot easier to do it geometrically. If it's multiple choice, they'll never know how you did it anyways. Okay, so what I have is I have 1/2 the base times the height. The base, as you can see, goes from negative a to a, making it 2a. The the y-intercept, of course, is 0a, which means this height is a. So it's 1/2 2a times a, which is a squared. Okay? And here's another one, same idea. The left is x equals r, the right is x equal negative r, sorry, the right is x equals r. They do tell you r is positive in the directions. Again, it's a half circle because it's y equals the square root of. If you square both sides, you'll get this circle. Oh, that's a terrible circle. But anyways, it's going to be only the top half because it's y equals positive, the square root of. So again, it's 1/2 of a circle. So the area is 1/2 pi r squared. You don't know what r is, so there's your answer. Not much you can do about it. Okay, so this is using the properties of integrals. It says evaluate the integral using the following values. Now, they don't think you know how to evaluate definite integrals yet. So as far as that you can be concerned, this is f of x all cubed, this is f of x, and this is 1. You don't know. Okay, all you know is the integral from 2 to 4 of this weird function that supposedly you don't know how to integrate is 60. 2 to 4 of this other function x dx is 6, and 2 to 4 of dx is 2. Okay, they don't want you using definite integrals or the first fundamental theorem of calculus. So here's number 38. So when you look at 2 to 4, notice they give you x cubed. So we're going to break that up in integral from 2 to 4 of x cubed plus integral 2 to 4 of 4. And then what you can do is simply come up here and go, oh, look, the integral from 2 to 4 of x cubed dx was given to me to be 60. And I can pull the 4 on the outside of this, leaving me with the 1. And of course, that's what they gave you right here. Integral from 2 to 4 of 1 dx is equal to 2. So you have 60 plus 4 times 2 is 68. Okay, here in 41 through 44, you have to use the properties because they don't tell, it's a mystery function. So they give you the integral from 0 to 3 of f of x dx is 4, and they also give you the integral from 3 to 6 of f of x dx is negative 1. Based only on that, they want to know what's the integral from 0 to 6, 6 to 3, etc., etc. Okay, well, 0 to 6, of course, you'll remember, is 0 to 3 plus 3 to 6. Well, they gave you the integral from 0 to 3, it's 4, and they gave you the integral from 3 to 6, it's negative 1. Add them together, you get 3. 6 to 3 means you're just going to take 3 to 6 and flip it, and therefore you have to put a negative in front, so it's going to be negative, negative 1, which is 1. 3 to 3, you don't even need any givens. If the limits of integration are the same, the answer is 0. And 3 to 6 of negative 5 f of x, you're just going to pull out the negative 5. And of course, they told us up on top that the integral from 3 to 6 was negative 1. Okay, consider the function that's continuous on the interval from -5 to 5, and for which the integral from 0 to 5 of f of x dx equals 4. Again, you don't know, it's a mystery function. So based on that, what's the integral from 0 to 5 of f of x plus 2? So you're going to split it up into a sum. Now, this, again, you would know how to integrate this by hand, but if you didn't, you could graph this. The top border is y equals 2, left border, right border. It's just a rectangle, a 5 by 2 rectangle, which is 10. And then the 4, they gave you the integral from 0 to 5. -5 to 5. Oh, good. I was going to say, yeah, the question actually says -5 to 5, given that f is an even function. This has big implications with definite integrals, because if it's an even function, that means it's symmetric with respect to the y-axis, which means when they give you the integral from -5 to 5 of some even function, you actually know that from -5 to 0 is going to have the exact same area as the from 0 to 5. So -5 to 5 you could look at as 2 times 0 to 5, which is 2 times 4, which is 8. But in the next one, what if it's odd? If it's odd, an odd function, it's symmetric with respect to the origin, in which case, let's pretend the areas were both 4, but the integral from -5 to 0 will be negative because all your f of x's are negative now. And the integral from 0 to 5 will be positive because your f of x's are positive. So now what happens is you'll have the integral from -5 to 0. They told you 0 to 5 was 4, which means if this is an odd function, -5 to 0 is -4. And if you add those together, you will get 0. Okay, now this is a very hot AP topic, which is up till now, all of our widths of our Riemann sum rectangles have been equal widths. Now, not so much. So here's an example. So your region is bordered by f of x equals sine x, on the left by x equals 0, on the right by x equals 2 pi. As you can see, your x0 is 0, your x4 is 2 pi. But now what they're doing, instead of dividing that region from 0 to 2 pi into 2 or 3 or 4 or 6 rectangles of equal width, they're going to have weird widths. So the first width goes from 0 to pi over 4. The next width goes from pi over 4 to pi over 3. The next width goes from pi over 3 to pi. And the last width goes from pi to 2 pi. Also, instead of inscribed, circumscribed, right endpoint, left point, or midpoint, they're telling you inside that first interval from 0 to pi over 4, you're picking this spot, pi over 6. F of this number is going to be the height of the rectangle. And then between pi over 4 and pi over 3, it's pi over 3, which is the right endpoint. Between pi over 3 and pi, it's 2 pi over 3, which is the midpoint. And between pi and 2 pi, it's 3 pi over 2, which happens to be the midpoint. Okay, so the width of the first rectangle is x1 minus x0. The width of the next one is pi over 3 minus pi over 4. The height of the first rectangle is f of pi over 6. The next height is f of pi over 3. So here's what we have. Here's your 0 to pi over 4. The next width was from pi over 4 to pi over 3. The next one was from pi over 3 to pi. The last one was from pi to 2 pi. The height, the first one was at pi over 6. The next one was at pi over 3. The next one was at 2 pi over 3. Remember, I'm going up and touching the curve. And the last one was at 3 pi over 2. Go down to touch the curve. Now, notice they didn't ask for area, which means some of these answers, these integrals will be negative, and you're going to keep them as negatives. Okay, because there was no word area mentioned here. Just evaluate the integral. So the first width is pi over 4 minus 0, which is pi over 4. The first height is the sine of pi over 6, which is a half, because your f of x is sine x. And then, etc., there's the next width, sine of, next width, sine of, etc., and you'll get negative 0.708.